Okay, welcome back to the 4.2 notes. And what we're going to do is we're going to graph this equation by using the first and second derivative tests on this function. And so, we're going to kind of put everything together here and do the first derivative test and second derivative test. So I do have this little thing called the curve sketching guide. Okay, and these are all the little things that we need to take into account when we're trying to graph something like this. So the first thing that I want to do is, let me go ahead and zoom in here and kind of talk about this. And so the first thing I want to do is write out our function, which is x to the fourth plus 2x cubed, okay? The domain of this function, because this function is a polynomial, okay, my domain goes from negative infinity to positive infinity, okay? And my range, because we have a polynomial of degree 4, we may be restricted here. But our range probably goes, I believe, from 0 to infinity, but don't quote me on that. I haven't looked at this graph, okay? But I'm going to put a question mark there. That might be the case. But we'll be able to check that here in a minute. Okay, let's talk about something else. Let's talk about x-intercepts. Okay, so to find the x-intercepts of my function, I'm going to take my function and set my function equal to 0. Okay, so if I do that, then I'm going to take x cubed, set that equal to 0, and set x plus 2 equal to 0. So I get x equals 0 as an x-intercept. Okay, and I get x equals negative 2. Okay, and all I'm doing is setting my function equal to 0 and solving for x. Okay, but that's important because we do need to know where those points are on the graph. Okay, y-intercept, I'm just going to plug in 0 into my function and see what we get, okay? So for my y-intercept, I'm going to plug in y equals 0 to the fourth plus 2 times 0 cubed, and that's just going to give me 0. So I have a y-intercept at y equals 0, okay, which is kind of nice. Okay, vertical asymptotes, we have none. Okay, we have a polynomial, so it's continuous and differentiable. Horizontal asymptotes, we also have none. Okay, we just have a polynomial. All right, so, those are little things that we just need to know how to do, okay? And let's go ahead and do our first derivative test here real quick. So I'm going to take my derivative of this function, and that's going to give me, what do we got? 4x cubed, okay, plus 6x squared, okay? And so what I want to do here, this is my second derivative, but I do want to do the first derivative test and set this equal to 0 and find my critical numbers. So I've got 0 is equal to 4x cubed plus 6x squared. And I'm going to go ahead and factor out a 2x squared here. So if I factor out a 2x squared, then I'm left with a 2x and then plus 3, okay? And all I want to do is factor this, and it's already factored. I can factor out a 2x squared, set each of those equal to 0, and solve for x, and that'll give me my critical numbers. So if I set 2x squared equal to 0, and I set 2x plus 3 equal to 0, okay, I end up getting, if I divide by 2, I get x squared is equal to 0. If I take the square root of that, I'm just going to get x equals 0. Okay, so that's a critical point. Okay, that's a critical point right there. And then I'm going to take this, I'm going to subtract 3 from both sides, and I get 2x is equal to negative 3, and then divide by 2, divide by 2. So I have x is equal to negative 3 halves. This is another critical point. Okay, so now what I want to do is follow my second derivative test, okay? And the other thing is here is that I do want to list out my critical numbers here, okay? Critical numbers, that's endpoints. We don't have any endpoints. Where our derivative is equal to 0 and where our function derivative is undefined, okay? Now, we don't have endpoints because our domain goes from negative infinity to positive infinity, okay? And we don't have anywhere where the derivative is undefined because our derivative is a polynomial, Okay, and because our derivative is a polynomial, we're good to go. All right, so now let's go ahead here, and I'm going to write critical numbers, CP. Okay, we have that at x equals 0 and x equals -3/2. Okay, so what I'm going to do here is I'm going to write out my interval. Okay, and I'm going to do from -infinity to -3/2, and then I'm going to go from -3/2 to 0, and then I'm going to go from 0 to +infinity. Okay, and that's it. All right, and you know the table's already kind of made there for you. So I'm going to choose a couple values to plug in. I'm going to plug in, say, -2, all right, into my derivative in between -infinity and -3/2. I'm going to choose -1. That's between -3/2 and 0, and then I'm going to choose 1. Okay, and so I'm going to go ahead and plug those in. And so I'm going to do that. I'm going to do that all the way over here to save some room. You may want to do this at the bottom of the page, but I'm going to go ahead and do f prime of -2. Okay, and I'm going to plug it into my factored form here. Okay, I'm going to plug that in there. I feel like it's a little bit easier to work with. And so I get 2 times -2 squared, okay, and then I'm going to multiply that by 2 times -2 plus 3, okay. And so this is going to give me, -2 squared gives me 4, so times 2 I get a +8. So that's going to be positive, and then I'm going to do 2 times -2, which is -4, plus 3, and so I end up getting that I get 8 times -1. Okay, so that's just going to be negative, all right? So what I know is that on this interval, okay, my derivative is negative. So that means that my function is decreasing here, okay? Now, I'm going to check, I'm going to plug in -1 and see what we get on that one. Okay, so I'm going to get f prime of -1, and that's going to give me 2 times -1 squared times 2 times -1 plus 3. So I get -1 squared, that's just going to give me 1, so I get 2 times -2 plus 3. Now, -2 plus 3 is just +1, so I get 2 times 1, which gives me a positive number. Okay, so let's go over here, let's put that this is positive, so that means that our function is increasing. So at -3/2, I have a minimum. Okay, and we're just following our graph to go from decreasing to increasing. We have a minimum here. Okay, now I'm going to plug in 1, and we're going to see what happens there at 1. Okay, so if I do f prime of 1, and that's just going to be positive. Sometimes you can just tell, so 2 times 1 squared times 2 times 1 plus 3. So that's 2 times 5, which gives me a positive number. Okay, so here's the thing. At 0, I have nothing's really changing here. Okay, I'm positive over both of these intervals here, and so I continue to increase. All right, but here's the thing. Okay, I have nothing here. I have neither a max nor a min. I have none. But we're going to do the second derivative test and kind of see what that does. All right, so let's go ahead and let's do the second derivative test. And I'm going to go ahead and calculate my second derivative based on what our first derivative was. And so that's what? 12x squared plus 12x. So my second derivative is going to be 12x squared plus 12x. Okay? And I'm going to set that equal to 0. Okay, so if I set that equal to 0, so 0 is equal to 12x squared plus 12x, then I know that I can factor out a 12x out of this. So if I factor out a 12x, then I'm left with a x plus 1. Okay, so if I set each of these now equal to 0, I'm going to set 12x equal to 0. I'm going to set x plus 1 equal to 0. And so I'm going to divide by 12, so x equals 0. That's a critical point for my second derivative test. And then I'm going to subtract 1 from both sides, so x equals -1. X equals -1. is another critical point on my second derivative, okay? So up here, I'm going to write critical points, critical numbers at x equals 0 and x equals 1, okay? So I'm going to do the second derivative test, all right, which is very similar to the first derivative test, but we're just finding concavity and points of inflection, okay, instead of where are we increasing, decreasing, and finding extrema, okay? So I'm going to do this. I'm going to do... my intervals go from negative infinity to 0. Wait, and this is -1, right? Let me come in here. This is a -1. Okay. So that changes this. All right. Let me come in here and change that. All right, let me erase that. So we go to negative infinity to -1, and then we go from -1 to 0, and then we go from 0 to positive infinity, okay? So let's figure out some points to plug in into here and check my second derivative. And I'm going to choose values of, say, like -2 here. I'm going to do -1/2 here, and then I'm going to do 1, okay? And so when I do that, I'm going to go ahead and do, I'm going to plug those into my second derivative. So I'm going to do f double prime of -2. I'm going to do that one first. And so I've got, what was it, 12x. So 12 times -2 times -2 plus 12, or plus 1. Okay, isn't that what I'm going to use? And I'm going to use my factored form here. Okay, just because I think it's a little bit easier to do the factored form. All right, so 12 times -2, -2 plus 1, let's see what we get here. And so this is going to give me -24 times -1, which actually is going to end up giving me a positive number. So this is a positive number, so my function is concave up on that interval, okay? And let's go ahead and plug in -1/2. So if I do f double prime of -1/2, that's going to give me 12 times -1/2 times -1/2 plus 1. And so then that's going to end up giving me -6 times a half. Okay, so negative times a positive gives me a negative. So I'm going to come up here, I'm going to write that this is a negative number. That means that our function is concave down, okay? All right, now let's plug in f double prime of 1 and see what we get, and that's just going to give us 12 times 1 times 1 plus 1. So we just know that's automatically going to be positive, okay? That's a positive number. So my second derivative is positive, so now we are concave up. Okay, so but here's what's happening at -1 and 0. Okay, these are values where I have points of inflection. Points of inflection, POIs, okay? So let's go ahead over here. Let's write out some of these, let's figure out what these points are, okay? And so what it wants us to find, I know that we have a minimum value at -3/2. So I'm going to plug that into my function. So I'm going to do this. I'm going to find f of -3/2. And I know that's going to give me a local minimum. But into my function, what was our function again? X cubed times x plus 2. So, and this is going to give me kind of a decimal number here, but I've got -3/2 cubed times -3/2 plus 2, okay? And I'm going to evaluate this, and this is going to give me -27/8 times +1/2, okay? So this is actually going to give me the value -27/16. Okay, so I have a minimum, okay, at the point -3/2, -27/16. Okay, so nothing too crazy. But then I do want to find my points of inflection. Okay, so I want to plug in -1 and 0 into my function. So if I plug in, if I find f of -1, okay, then that's going to give me -1 cubed times -1 plus 2. And that's going to give me -1 times 1, which gives me -1. So I have a point of inflection, okay, at the point -1, -1, okay? And then let's go ahead and plug in 0, so f of 0, and that was 0 cubed times 0 plus 2, which is just going to give me 0. So I have another point of inflection at the point 0, 0. Okay, so I can use all of this information now to help me graph my function, okay, without using a calculator. Okay, so I have some points on the graph that I have. Okay, I know where my x-intercepts are. Okay, I know that that's at the point x equals 0 and x equals -2. So let's go ahead and just plug those. Let's go ahead and just graph those. So I have a point here. And this, coincidentally, is also my y-intercept, and I have a point here, okay, at -2. All right, so now I know that we go from decreasing then to increasing, okay? And so that's at -3/2. So -3/2 and -27/16. That's going to be right. That's going to be right about here, okay? We had the value, all right, and we're just kind of eyeballing that. So but this is my minimum. Okay, this is my minimum. Okay, and that's the point -3/2, -27/16. Okay, and we're kind of just eyeballing that. Okay, I also know that I have the point 1, 1 here. Okay, and or -1, -1. That's a point of inflection, and then I have a point of inflection at 0, 0. Okay, so these are the only points that I know. All right, so here's what I do know. I know that we are decreasing to -3/2, okay? And then I also know that we're concave up between -infinity and -1, okay? So I'm going to have my graph do something like this, all right? I know we're going to be decreasing and we're concave up. I have a minimum, we're concave up. And then we change from concave up to concave down between -1 and 0, okay? Or at -1, we change from concave up to concave down, and then we hit 0. So watch how I graph this. This is kind of interesting. But I'm going to come in here. I'm going to make this concave down, okay? Concave down. So right here, this is a point of inflection, okay? And then I go from, and then at 0, okay, I go back to concave up. All right, and so if I come in here and I change this to concave up, but we're increasing, my graph is going to look like this. So at 0, 0, I have another point of inflection. And that's my graph, folks. Okay, and so it's pretty easy to do. If you know how to do the first and the second derivative tests, it can be a little confusing, but you know, this is a pretty standard question. So I hope you enjoyed this. I do want you to kind of do this and then get started on your homework. Okay, so let's go ahead and do that. Thanks.